Welcome everybody, a new Lunch and Learn of sustainable ships. Today we're going to talk about a product that originates from the sailing sports. It's America's Cup debut, as we can say. So it's a product that helps ships in their efficiency, and yeah, we're going to hear everything from it from Bruno. Welcome, Bruno. Thank you for joining us. The company is called Hull Vane, and yeah, I want to give the word to you, Bruno, so you can tell us everything about it, and so we can lunch and learn.
Thank you, Gijs, and enjoy your lunch in every case.
Thank you.
I will share my presentation. Then, in that case, I will start the presentation. My name is Bruno, and I'm from Hullvane, sales director. And what we do is we build wings for ships, basically. We build partial hydrofoiling solutions, not to lift ships out of the water, as most hydrofoils do, but to reduce their wave making and their resistance and make them more efficient and more comfortable. It fits very well with our philosophy in our company, which is that we should always strive to make ships better, more sustainable, more efficient, and more comfortable, and not be happy with the status quo. As engineers, we think we have to be curious and always try to find the optimum. That's very much in our DNA in our company over many years. I will first give a little bit of context about decarbonization and what Hullvane's role in that can be, and then explain how the Hullvane works, and then give some examples that show what we can do with Hullvane, and then there will be time for questions and answers. If we look at decarbonization in shipping, I think we quite often put the horse behind the carriage. We are talking a lot already about alternative fuels like hydrogen in an all or nothing approach. And if you draw the parallel with housing, what they say for houses is that it's best to first insulate the house and put LED lighting. And then you look at heat pump, solar panels. And there's two reasons for that. One is that you have a better payback if you do energy saving first, because you have actually payback on that, and alternative fuels are often more costly than diesel. And second of all, if you reduce the power demand first, it makes it easier to make the transition to a different fuel. If you draw that parallel to ships, and you want to reduce the emissions of ships, it means that you will first look at resistance reduction, which is energy saving, and only then look at alternative energy carriers. And if you look at the resistance or the fuel consumption of a ship and you want to do energy saving, we see that for most ships, most of the fuel goes into the main engines, 90%, quite often, or 95% goes to the main engine fuel consumption. And where does that go? That goes mainly in two sources of resistance: the frictional resistance and the wave-making resistance of a ship. For very slow ships, this is mainly frictional resistance. For ships at intermediate speeds, there is quite a significant part wave-making resistance. On top of that, you get a little bit of wind resistance and appendage resistance, but that's only a few percent. And what Hullvane does is we reduce that wave-making resistance. Here you see the graph of the resistance in terms of speed in knots and the resistance for a 50 meter. What can you do to reduce the wave-making resistance? Three main things, basically: hull optimization, which is done by many companies. Bulbous bow is a way to reduce the bow wave, the wave-making also, and a hull vane. So it has its place there, and for every ship that makes waves, it's worthwhile looking at which solutions can help you reduce that wave making and that wave making resistance. In many aspects, Hullvane is comparable with the bulbous bow. You add a little bit of frictional resistance, you add some complexity in the build, maybe, but once it's there and designed well and built well, it's fit and forget, and you have the benefit from it. Hull Vane, as told, was originated in the America's Cup, so it's a little bit like Formula One technology makes it to normal cars. This is America's Cup technology that makes it to ships. It is patented technology, and since 2014 we have started a business called Hull Vane BV to design, market, and build the Hull Vane as a full component, because shipyards who build ships or who service ships, they want to receive the Hull Vane as a component on a truck. And this we have been doing now for 8 years with great success. We now have 4 products: the custom Hull Vane, which we do on the larger vessels, and semi-custom Hull Vane, which we do on smaller vessels, which is a more standardized solution. We have the dynamic Hull Vane for increased pitch damping, and we have foil assist, which is a completely different solution for planing boats, which we call the shock absorber for planing boats, which can be used on yachts or commercial ribs, for example. And where do these products, where are they applicable? We look mainly at the fruit number, and this is a table with the fruit number in terms of length and speed of a ship. We also have on our website a calculator for this. It's very practical because it's a formula with a square root that you have to calculate. And Hull Vane sits in what we call the intermediate speed range. Foil assist sits in the planing speed range. If you go bottom left, you have ships like tankers and bulk carriers that often go very slow for their length, and they only have frictional resistance. This blue area in the middle, I would say, is about 5 to 10% of the ships, and the ship types are mentioned here on the right. So motor yachts, workboats, and crew boats, passenger ships, patrol vessels and naval ships, roro vessels or RoPax ships, and expedition cruise ships and research vessels. Foil assist is more for commercial ribs like crew transfer vessels, naval interceptors, and speedboats, yachts, of course. Then the working principles, how does the Hull Vane work? There are 3 main effects. And the first one is basic wing theory, like an airplane wing, except that on a ship, the flow is not coming horizontally, but coming from below. So it's coming upward. And what happens with a wing in a flow, we generate a lift force perpendicular to the flow and a drag force with the flow. And the funny thing is that the resultant of the two, the sum of the two, the green vector, is still angled forward. So we can uncouple it in a vertical part, which lifts the ship, but also a horizontal part, which pushes the ship. And that is the basic idea of the patent and the basic working principle of the Hull Vane. It's a net forward propulsive force. The second effect is that the wing will influence the wave pattern, much like a bulbous bow influences the bow wave. Here we create a low pressure on top of the wing, and that will bring down the stern wave generated by the ship. And you can see this in CFD images early on in the project, but it's even more clear in full scale. This is a 52-meter patrol vessel without Hull Vane, so before the retrofit, and you see a typical breaking stern wave. And this is the same ship at the same speed with the Hull Vane. And it's a difference in fuel consumption of 27% measured. But also you see that the people are talking here on the aft deck, which wasn't possible before because then the stern wave makes a lot of noise. So the effect is very visible in many cases. The third effect is when the ship is sailing in waves, is that the Hull Vane dampens the pitching motions. So you have less added resistance from the ship motions in waves. At the same time, this improves the comfort on board. And there's another effect that we know that contributes to this, which we call the pumping effect. When the ship is pitching and the Hull Vane is attached to the ship, the foil actually sees a variable angle of attack, and it creates more forward thrust. This Fx that you saw before gets bigger in waves, so that it starts to work as a kind of a propulsor. So that is another advantage, both for energy consumption, but also for comfort and operability on board, and safety even. Then some examples of ships in various segments. This is an offshore supply vessel built in the Netherlands. The shipyard did before and after trials to see what the Hull Vane did, and had it measured by a company. And on this vessel, the savings were 10 to 15%, 10% at 12 knots, which is kind of their idling speed, and it went up to 15% at 21 knots. 5 of these ships were built, and even though Hull Vane was an option, all of them were built with the Hull Vane. And there are very few crew boats. This is actually a crew boat or a fast supply vessel that you can see running at 20 knots like this one without any stern wave behind it. It's really a remarkable ship, also in waves. The second one is an OPV, so a Coast Guard vessel, offshore patrol vessel. And that is the vessel of which you saw the wake. And these are the numbers. At 12 knots, we had 18%, 15 knots, 27%, and 21 knots, 22%. And of course, the top speed, when you reduce the resistance, the top speed increases, in this case by 1.4 knots. It's a very good case to reduce the CO2 emissions. Over the year, because this vessel sails a lot at slow speed, it's about 20% reduction in CO2 emissions. This is another example of a patrol vessel in the port of Rotterdam. It was designed and built from the start with the Hull Vane. So that has advantages that you can use smaller engines, and the whole boat becomes lighter and more efficient because of it. And I believe 200 or 300 kilos of steel of the Hull Vane actually save 57,000 liters of diesel per year, which is quite amazing. And here we also saw that the easiest way to make a ship quieter, and many people forget that, we put a lot of effort in mega yachts, for example, to make them quiet. The easiest way to make a ship quieter is actually to improve the efficiency. The engines work less hard at a lower RPM. The propellers work less hard, so they also even cavitate less. And there is less noise from the stern wave, which can be a big source of outside noise. So it's exceptionally quiet. In terms of decarbonization, the same shipyard, which is Kooiman, built also 2 of these vessels for Antwerp, the port of Antwerp. And they can do full electric sailing on the batteries up to 11 knots. And this is that speed in model scale. It's a difference of 25% in power consumption. So the range of the boats is increased by about 33% in full electric mode. And I wish there would be a spoiler for electric cars that gives you 33% extra range, but air is not as dense as water. So it unfortunately doesn't exist, but for some ships it exists. This is a passenger vessel on Lake Geneva. And here you see the boat with Hull Vane and a bulb and without. And we know from the CFD that the Hull Vane is responsible for 15% lower fuel consumption. It's very easy because it's a liner service. You can fly there and board and see the Hull Vane in action, which is something I frequently do with clients. This is a yacht, mega yacht. We do actually half of our projects are for yachts. They don't sail a lot, so the fuel saving can be limited, but often it's already paid in the build. Like in this case, the builder could scale down the engines from 16 cylinders to 12 cylinders. And the other reason to do it on yachts is, of course, the reduced noise and the reduced motions in waves, which makes clients enjoy their yachts more. But of course, over time, it also pays back in fuel saving. This boat is now sailing for 8 years almost, and it has skipped 1 in every 5 bunker stops because of the Hull Vane. So then some CFD studies of bigger vessels. This is an expedition cruise vessel. So at 130 meters at 15 knots, which is a very typical speed for an expedition cruise vessel. And there we have 9.6%. So very worthwhile looking at, both for efficiency, because expeditions cruise vessels do long distances quite often in rougher weather, but also for comfort, because the clients are not used to a smaller vessel. They are used to the very big cruise vessels, which don't move at all. So for both seakeeping and efficiency, this is very worthwhile looking at for expedition cruise vessels. Then a typical cargo vessel. This is the E-series from Abyss Shipping. There are about 6 of these ships. And the saving there at their normal operating speed, they have a top speed of 18 knots, but they sail usually at around 14 knots. And we have 5.2% less resistance. So it's a very, these kind of ships, people don't think immediately about Hull Vane, but it's still very worthwhile looking at for cases like this. Same for this. This is a RoPax, a large RoPax vessel, 170 meter, 6% less resistance at their normal operating speed of 20 knots. So that these are examples that you can do. Then some boats that are under construction. On the left is a fishery inspection vessel for Denmark, designed and built with Hull Vane from the start. You can see it here because it's still in the outfitting phase, so the Hull Vane is actually at the water level. And this is the Holland class. It's a 108 meter OPV of the Dutch Navy, where we are actually finalizing the construction of the Hull Vane, which will be retrofitted early next year. And in this picture on the left, we thought this was already a big Hull Vane last year, but then this year we took the picture on the right with a much bigger Hull Vane. We are now very close to an order for Hull Vanes, for 4 Hull Vanes that are actually even a lot bigger than this one even. So there's for us no limit in size. We go from boats from 10 meters, can be up to around 200 meters. If we go bigger than 200 meters, most ships, they do their slow steaming and super slow steaming. But for us, the size is not a challenge. It's the speed to length ratio, which is most important. Then we have the dynamic Hull Vane, which we can actively control with a small gyroscope. We do that together with a stabilizer manufacturer called Naya Dynamics. And this allows to reduce the pitch damping even more. So with a passive Hull Vane, we get 10 to 20% pitch motion dampening in their resonant pitch motions. With the active or the dynamic Hull Vane, we can increase that to 30, even 45% pitch motion dampening at displacement speeds. And there are other systems to reduce pitch motions, like interceptors or trim tabs, but they start to be effective only at speeds over 20 knots. And many ships in heavy weather, they don't sail such a high speed. So I think this is one of the very few, or maybe even the only system which is very effective at the speeds that ships actually sail in waves. At the same time, it can be switched off, and it is in all respects the same hydrodynamically as a passive Hull Vane. By coincidence, this is a U-shaped Hull Vane, but it can be a TT-shaped as well. There are many possibilities. So now we have sold around 55 Hull Vanes, and we have more than 40 in operation. We have built 8 foil assist systems for clients. We have 9 repeat customers who have tried Hull Vane on one ship and then ordered for another one. And I think that's the best proof of concept that you can have, because everyone wants to try an innovation, but to then invest in more vessels, it's clearly a sign that people are convinced. It's proven both in effectivity, because we do a lot of retrofits, and there you can easily do a before and after trial, and also in long term, because the first ships have now been sailing 8 years already with Hull Vane with no problems at all. So it's a very simple, effective solution. Accumulated, we have saved 12,000 tons of CO2. the projects that we are now talking about, we are talking about saving about 7,000 tons of CO2 per ship per year. So this number is going to go up really quickly in the coming years. So summarizing, you reduce the operating costs by fuel consumption and the greenhouse gas emissions, of course. On new builds, we can reduce the build costs quite often by installing smaller engines and exhaust systems for the same top speed. And then also reduce the weight and the space needed for the propulsion installation and the fuel tanks. The nice thing is there is a benefit for the users, the improved seakeeping and the reduced noise on board. And Hull Vane is very suitable for ships with a wide operating profile, where you have to combine a relatively high top speed with a lower service speed, for example, like patrol vessels or yachts or naval ships. And last but not least, efficiency is silence. It's often overlooked, but it's the easiest way to make a ship quieter, is to make it more efficient. So I will stop sharing the presentation, and then I'm open for questions.
Well, first of all, thank you, Bruno, for your very clear presentation about the Hull Vane.
Thank you.
I've got a question for you. If you put the wing at the back, but if you look at sports cars or something, they've got wings everywhere. Is it possible for a Hull Vane to put wings at different places on a yacht to make the efficiency go up even more?
Yeah, for L'Assist is an example of that. It's that wing is placed midships on planing boats, and it takes about half of the weight of the boat on the wing. And with that, the boat runs lighter, and most of all, it has less effect from the waves. On a displacement ship, we know that it's quite tricky quite difficult to save energy with the wing forward. Usually you need to have a reduction in motions in waves or something like that before you can get a benefit from a wave, because any appendage that you add on a ship normally creates drag. And this is the unique thing about the Hull Vane, that it has a negative drag. And that is really due to its location at the back.
Yeah, okay, thank you. Someone else a question? Vincent?
Yeah, absolutely. I had a few. First of all, thank you very much, Bruno. The last comment you made, the negative drag due to the location, that's of course good to keep in mind. It has to do with everything has to do with the flows, of course, which got me thinking. In one of the previous lunch and learn sessions, we discussed eco speed. That's you're very much experienced with the product, I believe, the coating.
Yeah.
Do the effects of eco speeds and Hull Vane compound? So
yes.
If you have
they are not interlinked, and Hull Vane is quite much uncoupled from all the rest of the things. Actually, we have painted 2 Hull Vanes already in eco speed, and it seems like a good solution to get long-term fouling protection and durability protection.
Yeah.
But eco speed is something that works on that frictional resistance, avoiding the addition of frictional resistance from growth.
Yeah.
And Hull Vane works on the pressure resistance or wave making resistance. So they're perfectly combinable, and also even with systems that give alternative propulsion, like wind propulsion. It's a very good combination. Air lubrication, things like that. That there is no conflict with any of the other energy saving devices. Of course, you cannot add the savings percentage plus. Like some people think, if I add them all up, I get fuel back in the tank.
Yeah.
What you have to do is multiply the efficiency. So if Hull Vane saves 20%, that's 0.8 efficiency, and the other gives 10% is 0.9. Then together they will have 0.72, so 28%, for example. That's a mistake many people make.
Yeah, I was almost making the same mistake. Thanks for keeping that in mind. Yeah. Okay, so maybe if I may be so bold, how much does it roughly cost? What would be the payback rates for the ship owners?
This very much depends of the ship, the savings we get on a specific ship, and we can with CFD very early on in the project we can tell the client what it will actually do and what it will cost, and then the payback period depends of how much is the ship sailing. For example, the RPA 8 of the Port of Rotterdam, they are sailing a lot. I think 4,000 hours per year, and its payback period would be 1 year, except that they already paid for it during the build with smaller engines. So then it's zero. In retrofit cases, it can vary from 1 to 6 years. It can be longer as well, but then often the client will not do it if the ship is so. But it's important not only to look at payback period, but to look at all the advantages. And some clients do it for other reasons, and then they take the payback period as an added bonus.
Yeah.
Or they do it for the savings after the payback period, which can be huge. Sometimes the payback period is not all that relevant. You have to look at the whole life cycle of the vessel, the remaining life cycle, and what you can really save on that.
Yes, as you mentioned, comfort, speed, but then summarizing also a reduction of cost, reduction of fuel, emissions. Why doesn't everybody do this?
That's a good question.
Yeah.
It's quite often what we see is that it's easiest because it's an innovation, easiest in small organizations where the shipyard manager is also the project manager, or the ship owner is very involved with the technical aspects, or a superyacht owner who sees it and says, I want this.
Yeah.
The difficulty is, for example, in the offshore industry, where one company owns the ship, another is the technical manager, a third one charters the ship and pays the fuel.
Yeah.
And that's what I call the split incentive. But there are solutions for that, like, for example, financing, or on a crew boat, the owner can charge a higher day rate if the vessel is more efficient. That's sometimes it's very funny if you ask a ship owner, they say, "Yeah, I want a payback period of 2 years," and they say not 3 years, they say 2 years. And at the same time, if you say, "Okay, but would you be willing to pay €100 more in day rate to save 250 euros per day in fuel?" They say, "Yeah, of course, it's a no-brainer." But that is a longer payback period than what they initially said. That's so.
Yeah, that's you put it quite nicely in words. That's exactly the same kind of incentives that we see in the industry as well. It's very much day rate OPEX optimized. Yeah. Sometimes hard to sell something that gives you a lot of money back in the whole life cycle, but you have to pay up front.
Yeah.
If I can give a small addition to this, what we feel in yachting, mainly the yachting industry, it's not commercial, but it's the same product, but different goals somewhere. We really feel that the market is really conservative. It's really like first see, then believe, and it's kind of a gray area, and people are really a little bit skeptic. And then after we did a project with them, they really turn into a representative, and they really like it. But there's a really conservative vibe still. So actually, after all those cases we did, after everything we proved, it's still really people are really holding back, and
you need to have
we are going through. So
everyone, the builder, the owner, everybody, the owner's rep, everybody needs to be on the same page, basically. But we have to nuance, because between the first bulbous bow and the second bulbous bow, there was, I believe, 30 years. And we have, within 8 years, already sold more than 50 Hull Vanes. So it is slow because of the conservatism, but actually it's going quite fast.
Yeah.
Maybe linked to that, I have a question about, can you maybe give a quick estimate about the fuel savings, for example, or the payback time, or that you give a small estimate upfront instead of doing the CFD simulations, because maybe that also helps to get the ship owner on board. and they can see, okay, these are the savings for my ship, and I don't even know if it's like 10% off or 5% off, but you have a certain range, what you can expect. Is
Yes.
that true or not?
It's always good to contact us, because sometimes we have done studies on a very similar ship, or actually on the vessel themselves, and the clients don't even know that. So we can indeed give quite often an estimate, or if we don't know, if we really say, okay, this is very far from everything we've studied, we propose a CFD study, but then owners never pay for study work if the Hull Vane doesn't work on their ship. So you can never lose by contacting us. That's
it. Perfect. Yeah, thanks.
I was triggered by something Peter just said. Also, particular clients. You spoke about Navy clients. Wouldn't they be extremely interested in putting these kinds of products in all their vessels? Because silence is, especially for, I don't know, submarines, but probably it works where you put it on top of the submarine as well. So how does the Navy work with these types of ideas or innovation?
The navies are extremely interested in this, and we have invested over the years a lot. We go to naval exhibitions and conferences. At the same time, when shipbuilding is conservative, you could say the Navy is that in a higher level. So a lot of the navies are actually looking what we are doing with the Dutch Navy, and the Dutch Navy is really opening doors for us by installing the Hull Vane on the OPV, where we expect more than 10% savings over the entire speed range. It is a fact. What I say to navies is, don't wait for the Dutch Navy. Select a vessel. In every navy has smaller vessels or older vessels, or try it on a vessel so you have first-hand experience with it, and then you can go build from there. It's not necessary to sit waiting to look what somebody else does. We have done many studies, also model testing on naval ships, and quite frankly, under the waterline, the difference between a naval ship and a super yacht, for example, is not that big. They have the similar displacement, similar speed, similar hull shape. So, but by nature, they are conservative, and even builders say sometimes we have to pull drawings from the closets from 20 years ago because they say it has to be a proven design. We know we can do better now, but we're not allowed. That's a little bit strange, because they do want up-to-date weapon systems, radar systems, but on the ship side, on the platform side, they tend to be very conservative.
So, and then, bottom line, all the ships are pretty much alike when they're in the water on the bottom. So are there any vessels on which the Hull Vane does not work? Or does it has to do with the speed and length ratio that you mentioned?
It's speed and length ratio, and also hull shape. For example, many ferries are around 200 meters are built with a very hollow and flat aft chip. So they have low wave making resistance, but a little bit more frictional resistance. The water goes more around the bends under the waters, and these vessels, they don't leave any stern wave, and that's a ship type that, for example, Hull Vane doesn't work with. But it makes sense to compare for a new vessel, for example, a more pram type hull with a Hull Vane to a ship like that. It's
great.
I've got another question, a bit on another question, but is it still used in the sailing sports, or did you quit Hull Vane in sailing sports?
What happened in the sailing sports is we optimized the Hull Vane for this America's Cup sailing yacht in 2002, and their top speed was then 10 knots. They were full displacement yachts, and now in the competition sailing, they are either planing, like in the Volvo Ocean Race, or fully foiling, like in the America's Cup. So Hull Vane has its place on sailing yachts, but then more on the cruising motor yachts, the motor sailors, or yachts with a bit more displacement than a very light modern sailing hull, it doesn't really have its place.
Yeah. Okay. Well, thank you. Someone else still have a question? No. Well, then I want to thank you again, and
I want to thank you.
yeah, welcome. I think it was a really learnful lunch. I learned a lot, at least, and I hope the other ones did as well. So, well, thank you.
Thank you, and have a
Thank
good
you.
weekend.
Thank
You're
you.
welcome.
Yes.
Bye.
Thanks.
Thank you.
Bye.
Bye.
Bye-bye.
Bye.
Blijf je nog...
Ja, ik zal de opname stoppen.
Ja, dat even